Dear students, today we learn the conservation of linear momentum. So, according to the principle of conservation of linear momentum, if net external force acting on the system is zero, the total momentum of the system is always remains conserved. So, let n number of particles each masses m1, m2, m3 and so on mn are moving with a speeds v1, v2, v3 and so on vn. So then moving with a vn, then total momentum here, total momentum P equal to m1 v1 plus m2 v2 plus m3 v3 and so on mn vn here. So by the Newton's second law, force is nothing but a rate of change in momentum dp by dt. So according to the statement, net force is zero, that is d by dt of total momentum is m1 v1 plus m2 v2 plus m3 v3 and so on mn vn here. So it is zero, so that means m1 v1 plus m2 v2 plus m3 v3 and so on mn vn equal to 0. From this statement, the total momentum remains conserved. So alternate method also there. If two masses are moving on the same line, m1 moving with u1 speed, m2 is moving with speed u2, if u1 is greater than u2, after some time they will be collide. So that means m1 m2 are collide here. After collide, let it be the velocity of m1 is v1, m2 is v2 here. So while here collisions of force exerted on m1 and m2, let it be f1, force acted on m2 by m1, let it be f2. Two forces are equal and opposite direction it is acting by the Newton's second law. That means what? F1 equal to minus f2. Minus means opposite direction. So for m1 body acceleration here, so a1 equal to v1 minus u1 by time interval same. For reaction time both the collide is same. For m2 body acceleration a2 equal to, that is v2 minus u2 by time same. So that means from the f1 minus f2, that should be, we will consider as m1 a1 minus m2 a2 here. So m1 a1 nothing but a v1 minus u1 by t, that is minus m2, a2 nothing but a v2 minus u2 by t here. So reaction times are cancelled. m1 v1 to can expand here, m1 u1 minus m2 v2 minus of minus plus m2 u2 here. Now you transpose all the similar terms, m1 u1 plus m2 u2 one side, and final velocity after collision m1 v1 plus m2 v2. That means the total momentum before collision, that should be equal to the total momentum after collision is always equal. So that means by the conservation of momentum, the total momentum before collision of the system equal to the total momentum after collision should be equal. Hope you understand. Thank you.